Alrighty guys, this is the last video for Chapter 7, or one of the last videos for Chapter 7. You have Honors Algebra 2. It is 7-7, which is called Base E in Natural Logs. So we're going to change gears here for this section as far as what we've been doing. Like pi and the square root of 2, okay, so we know pi, 3.14, and you know the square root of 2. The number E is irrational. Okay, so now we're going to learn about this number called E. If you look at your calculators, let's see where it's at. You can see it right there. Okay, can't really zoom in at all, but it's right there, right above second ln. Okay, and we're going to learn what that ln button means today too. Basically, it's referred to as the natural base E for a lot of reasons, which we're not going to get into. You can write equivalent base E exponential equations for a natural logarithmic equation by the following. That's a lot of words. Basically what it means is this. A natural log, if you look here, ln of 4 that we just saw, equals x. It's just a normal log but with a base of e. Okay, so instead of writing log base e of 4, you can rewrite that as natural log, ln of 4. So that's the only difference. The natural log is just a normal log except a base of e. So like how common log has a base of 10, natural log has a base of e. It's just fancy writing, okay? You can still then, as you see from the flow of the problem here, you can still then do a switch. So you can go log base e of 4 equals x, switch 4 and x, cross out your log, e to the x equals 4. That's important because we're going to do a couple different switches and then rewrite as natural logs as we go through today, and then learn some different things as we work through with these logs, natural logs. So it's another log with a special base. There's two logs with special bases. Your common log has a base of 10. Natural log has a base of e. Okay, so first off, we're going to get some practice. We're going to write each exponential equation in logarithmic form. So what we're going to do is we're going to take the log. We're going to make log base e. Oops, not 8, log base e. There we go. 8 comes to the left, equals x. Okay, like you switched before. And the only difference is, since this is fancy talk for natural log, you rewrite it as natural log. So natural log. Okay, so ln, of 8 equals x. It's ln is your natural log. I know it's backwards. It comes from the old roots of words and stuff like that. So I don't know exactly why. I think it's, if I'm not mistaken, it's supposed to be like log natural or something like that. But I'm not 100% on that, so don't quote me on that one. But it's ln of 8 equals x. So first question today is going to be, you guys rewrite this one. So e to the 5th equals x. Rewrite that into logarithmic form. Okay, so hopefully you have put ln of x equals 5 when that switch happens. So it's the same switch. The only difference is that you're writing log base e instead of leaving it as log base of a number. You're rewriting log base e as ln. All right, so now we're going to go the other way. We're going to do lateral logs into exponential forms. Okay, so to do this, you have to know that natural log has a base of e. So log base e of x is equivalent to 0.77 or approximately 7741. And once you have like that, then you can do your normal switching and drop logs. So you switch x and this decimal, and then you drop your log. So e to the 0.7741 is approximately equal to x. As you can probably guess, the next question is for you guys. Natural log of 10 equals x. Take that expression or equation, rewrite that into exponential form. Okay, so hopefully you put down e to the x equals 10, using your caret for your exponent. There we go. That's the word I'm looking for. So Other than that, with these questions, like you will have to know how to do some switching with your natural logs. Another style question that comes up in this section is one like this, where we're going to take an expression and rewrite it in as a single logarithm. Basically, it's going using your 7.5 properties. I don't fully understand why it's not in the 7.5 section, but they do show it here. I don't do a whole lot with this. This is more of a college algebra topic than it is an algebra 2 topic. Rewriting in single logarithms and expanding into big logarithms. But we're going to do, I have one here for you that I'm going to show you. So basically what you want to do is apply your properties so that way you can combine this all into one expression. So what we're going to do is we're going to first take the 2 and move it up, make it an exponent. So we're going to have natural log of 40 plus natural log of 1/2 squared, which ends up being 1/4, plus natural log of x. The basic of it is to tell you, you can, all the log properties that you used in 7.5 when we did the, combining with multiplication when we were adding two logs, dividing them when we were subtracting, and then moving your exponents, they apply to natural logs too because they're just normal logs. They're just fancy logs with the base of e. So since these are all pluses and sums, you can rewrite that as the natural log of 40 times 1/4 times x, and then simplify, 40 times 4 times x, which becomes natural log of 10x. You'll see a few of them in your homework. It's not going to be a pressing issue. Yeah. So you'll see a couple. Get some practice with that. It's just applying your properties. Not a huge issue. The big one, and obviously you can see the slide change color because this is super important and it's vibrant. I thought it was pretty cool to make the whole slide pink to make it make a point. Something we're not going to hit on too much in here, also because it's kind of college algebra topic, at least not yet, because natural base and natural log are inverse functions. So the natural log and the base of e are inverses. You can introduce them into equations to undo or to eliminate one another. For example, if you have e to the ln of x, this e, this ln cancel, and you have just this x left over. On the other side, if you take the natural log of e to the x, you have just x. So that's kind of where the rest of the day, the rest of this video, these equations we're going to do stem from, because that's how we're going to have to get our exponents down now, is because of these, and to cancel these out. This is how you're going to do it. When you have a natural log, you're going to take the e to both sides. When you have an e, you're going to take the natural log of both sides. So we're going to kind of work one, not super slow, but a little slower than normal probably. We have the first one here. We have 4 times e to the negative 2x minus 5 equals 3. And we're going to round that to the nearest thousandth. So first thing we want to do is get rid of that 5 right here. So we're going to add it over, which will give us 4 e to negative 2x equals 8. Now, if you looked back at the last slide, there was no numbers in front of e's when we took the natural logs of any of them. So then we're going to basically divide by 4, get rid of the 4 in front of the e. So divide by 4 here and here. It's going to leave us with e to the negative 2x equals 2. Okay, so now, since we're basically what you're going to do is you could still do what you've always done, and that's take a log of both sides from last section. The reason, though, we're going to do a special log is because of this base. So we're going to take a natural log of both sides. So ln of e to negative 2x equals the ln of 2. The reason we're doing a natural log is because there's a rule in logarithms that say if you have the same base, if you have the base on your log being the same thing as this, what you're taking the log of, essentially they cancel out. and you're left with the exponent itself. So this is a natural log, which means it has the log of a base e. You're taking the log of e, so those all cancel. So you basically bring this down, and this all becomes 1. So the whole left side cancels out to be negative 2x, which equals the natural log of 2. It's a pretty complicated step, but it's how you're going to cancel out that e. Otherwise, you have to take the common, if you would take the common log, you would have a common log, bringing it down, it'd be a complete mess. This way, you cancel it out. And it works with any base. Okay, so I'm going to show you guys after we finish this problem with what I'm talking about. Hopefully it helps it make a little more sense. To finish this problem, though, we're going to divide, obviously, both sides by negative 2. So x equals natural log of 2 divided by negative 2. We're going to plug that in our calculator, and hopefully, remember close parentheses on natural log. I'm going to tell you right now, it's going to be negative 0.347. And like I showed you where the natural log button is earlier. So to hopefully make this make a little bit more sense as to why this works, I'm going to revert back to common logs on our calculators. So remember that a common log has a base of 10. Okay, so I'm going to take the log of 10, and that's going to tell me 1. And now I'm going to go take the log of 100, and it's going to tell me 2. And I'm going to take the log of 1,000, it's going to tell me 3. And those are the 3 I can make fit on the screen, so that's where I'm going to stop. Now, if you think about this, remember this log has a base of 10. So log base 10 of 10 equals 1. Remember that the exponent on 10 is 1 here. Okay, so log base 10 of 10 equals the exponent that was on 10. Log base 10 of 100. Remember how you can rewrite 100 as 10 squared. So log base 10 of 10 to the second equals 2. Same thing here. Remember how you can rewrite log 1,000. Log base 10 of 10 to the third equals 3. Okay, just to show you I'm not BSing you, watch this. Log base 3 of, let's go bigger, let's go 81. It's going to be 4, because remember you can rewrite 81 as 3 to the 4th. So that works with all of those natural logs. That works with all the logs. That's a general log rule. So that's why it works, because whenever you take a natural log, its base right here is going to be e. So if I take the natural log of e to the third power, it'll tell me 3. Okay, so that's why this cancels out. So this all becomes basically allows you to bring the exponent down. The natural log and the e cancel each other out. So that's how this works. As you can see, you got a question sneaking up on you real quick. It's going to be your first problem to solve. Let me find custom current slide. There we go. So this one's for you. You have 3 times e to the 4x minus 12 equals 15. Just round to the nearest thousandth. Okay, so pretty much the same exact process. You're going to add 12 over first to give you 27. Divide by 3 to give you 9. Take natural log of both sides. Brings the 4x down. Cancels these out. So you have 4x equals natural log of 9. Divide by 4. Plug in your calculator. X equals 0.549. Okay, so hopefully that process is making a little more sense. If it's not, please talk to me in class about it. So now we're going to switch gears, and now we're going to go the other way. I always feel like this way is a little tougher to comprehend. So now we are starting with a natural log, and we need to get rid of it. So if you notice the first two, we started with e's. This one, we're starting with a natural log in our problem. You're going to start this one the same way. You're going to isolate the log, isolate the e. So we're going to divide both sides by 3. So the natural log of 4x equals 8. Okay, now, off to the side, before I move on, I'm going to write this old problem down. So it would be 2 to the 2x plus 3 equals 2 to the x plus 1. Something like that, something simple. The question I have for you now is, in that problem, what would the next line of work be? Okay, so from here, think back to when you recognize this, the next line of work would say what? Okay, hopefully you said you would either wrote it out or you said you set the exponents equal to one another, but you have 2x plus 3 equals x plus 1, and then you would solve it, okay? Now, instead of doing from here to here, I'm going to go from here to here, okay? So you can do this as a two-way street. You can set these expressions to exponents underneath any base. The base I'm going to pick is e. All right, so I'm going to take e to both sides. So the right side, to make it make sense, first I'm going to do e to the 8th. The second left side will be e to the natural log of 4x. Okay, now think back to that pink slide when it said e to the ln of x equals just x. Okay, well x can be whatever is right here. In this case it's 4x. So e to the ln cancels, the 4x comes back down. So you have 4x equals e to the 8th. You divide by 4, you get x equals e to the 8th divided by 4. Okay, and just showing your calculator for that one, since I probably haven't really talked about it yet. If you notice, you can go second. You can go second, natural log, that brings up your e. Okay, it puts me right up to the exponent, so e to the 8th. The key part here is, notice how that little flashing arrow stays in my calculator. So I don't want to go divide by 4 right now, because then I'm just going to do e to the 8th divided by 4, and all in the exponent. So it's just going to spit out e to the 4th. Make sure you get yourself out of the exponent by hitting the right arrow one time. So see how now you have a flashing term down here. So now you go divide by 4, hit enter. So there you go. You get 745. 239. The next one is 4, so I think I put 240. 239 would work either way. It says 1,000, so it should probably be 239 on that answer. Okay, so it's same kind of concept as the last one. A little bit different problem here. We could have one like this. Solve the natural log of x minus 8 to the 4th equals 4. Since you already have the natural log isolated, your first step could be to take the e's of both sides. So raise them to an e power. So e to the ln of x minus 8 to the 4th equals e to the 4th. Remember, the e to the ln part cancels out. You have x minus 8 to the 4th equals e to the 4th. And hopefully we remember from chapter 6 that to undo the 4th powers, we're going to take 4th roots so that they cancel out. So x minus 8 equals just the number e. We're going to add 8 to that. So e plus 8. Alright, so if you have to write that one down real quick, hopefully that one makes sense. Like I said, you start by taking the e's of both sides like we did on the last one. The left side cancels out. You're left with just the binomial to the 4th power. Take a 4th root right here. I didn't show that. I can do that here in yellow. Take a 4th root of both sides. That way the 4th power is canceled. You're left with x minus 8 equals e. Add 8 to both sides, you get e plus 8. Okay, when you do your calculator on this one, gosh, I'm talking fast. Even I recognize that one. Sorry, guys. When you do it this time, make sure when you go get e, because you still have to put it to an exponent, make sure you put it to an exponent of 1. Okay, then plus 8 equals to 10.178. Okay, so it's all working with your calculator. A lot of it is. It's a lot of algebra skills. And making sure that you understand what you're doing whenever you cancel out your logs. It's those 3 main things. The nice part about logs, not really nice, but the cool part is that now you can start doing different solvings of the word problems from earlier in the chapter. And before we do that, we're going to move into the different type of interest problem, which is called continuously compounded interest. So this is the second formula you have to know. You have calculate continuously compounded interest by using the following formula. A equals P times e to the RT power. The nice part about this formula is all the variable terms stay the same. A is still the amount after T number of years, P is your principal, R is your rate, T is the time. So everything stays the same. The only difference is it's a little smaller formula. I call it PERT formula, A equals. And the nice part now, or at least for me, maybe not for you guys, but now I can ask you all different kinds of questions because now you know how to bring exponents down. So this goes for what we're going to talk about now. This goes for whenever I ask you 7.2 questions also, because now you know how to bring down exponents, which we didn't know when we did 7.2. Now you do. So there could be some compound interest problems, non-continuous, where I ask you different questions also. So we got one problem to work through. Let's begin so we can get this video overdone. So when Angie was born, her grandparents deposited $3,000 into a college savings account paying 4% interest compounded continuously. Number 1, assuming no deposits or withdrawals, what will be the balance after 10 years? So remember for this, your formula is A equals P times E to the RT power. So that's what we're going to use for number 1. So I'm going to take this part by part, and once we're done with the parts, obviously I don't have a lot of room to work with, and I write big. Go part by part, and then I'll shrink it down. So part 1, we want to know the count or the amount of money in the account after 10 years. So we're looking for A. So A equals the principal amount's $3,000. We don't know. We know E. We know the rate is 4%, so as a decimal that'd be 0.04. And we know the time is 10 years. So we have A equals 3,000 times E to the 0.4 power. And when you do that one in your calculator, hopefully you get that one right. I'm not going to show that work because I don't want to destroy my drawings. You should get $4,475, and I believe it's rounded up to 47 cents. So there's part A. Straight plug and chug, just like it used to be. We'd always solve for everything prior to this one. Now that we get to number 2, that's going to change. So let me shrink this all down, move it to the side. That way, if you still need it, it's right there. It's just tiny. Okay, number 2. How long will it take? Can't really see the blue, can you? How long will it take for the balance to reach $10,000? So now we know where we want to end up. We want to end with $10,000. We're still going to start with our principal of $3,000. We still have the E. We still have the 0.04 interest rate. What we don't know now is how long. We don't know T. So now you want to do a couple of things. The first thing I would do is get rid of, since this is just a number that times the E, you can divide both sides by 3,000. So that's what I'm going to do, is divide both sides by 3,000. So I'm going to get, because I love fractions, 10/3 equals E to the 0.04 T power. Now that I have E isolated, I can take the natural log of both sides, just like we've been doing. So the natural log of 10/3 equals, remember the natural log and E cancel, so I'm just going to rewrite it to 0.04 T. And then divide all of that by 0.04. So the natural log, this is important here, so natural log of 10/3, and all of that's divided by 0.04 is equal to t. Then you should get t to roughly be, when you try it in your calculator, I believe it should be 30.099, and since it's a real world problem, you can say about 30 years. Okay, so there's number 2. So you still use the natural log from last time, bring the exponent down, and then solve from there. Shrinking that one down. Oh, where did it go? Okay, there it is. So now for number 3, last one. Here we go. If her grandparents want Angie to have $10,000 after 18 years, how much would they need to invest? So now we know where we want to end up. Now we just need to figure out how to get there. This one's easy. Number 2 was the hard one. 3 is somewhat easy too. So we have 10,000 equals, we don't know the principal, but we still know we want the rate of 4% and we want 18 years. All you have to do, evaluate that. So 10,000 equals P to the e power of 0.72. Now remember how e to the 0.72 power is just a number, so we're going to divide both sides by that number. And so we're going to get 10,000 divided by e to the 0.72 is going to equal P, which your last question here is to evaluate that in your calculator. So what is 10,000 divided by e to the 0.72 going to be? Okay, hopefully you put the answer in as $4,867.52. So that would be the principal amount that they need to start with in order to make that happen, that she has $10,000 after 18 years. Okay, it's a lot of information, guys. I know it was a long video. Thanks for sticking with it. As always, if you have questions, talk to me, see me, email me, whatever you want to do. Last assignment for the chapter is going to be page 505, 13 through 18, 34 through 36, 40, and 47. I don't have it wrote down that there's inequalities, but as always, in case there are, make sure you change them inequalities to equal signs.